Alrighty, so here we're just comparing the linear functions we've been practicing, the quadratic functions we've been practicing, and the exponential functions we've been practicing. We're going to compare the shapes of their graphs when we sketch them on a Cartesian plane. We're going to compare their equations, what they look like, how we can recognize these functions, these different functions from their equations, and we're going to take a look at when we see a table of values with these kinds of relationships, how we can recognize those from performing a few tests that we've already learned how to do in this course. This video is suitable for you in a 3C, that's a grade 11 college prep course, or a 2D grade 10 academic class here in Ontario. The prerequisite skills, frankly, are all of the work that we've done with our linear functions, quadratic functions, and exponential functions in this course. That is being able to graph them. That is being able to take them with equations, put them into tables of values, and being able to work from a table of values to find these general shapes. Now, in order to get through this lesson, we're going to rely on Desmos, which I've already set it up. So there are a whole bunch of different shapes right here. We're going to turn some of them off so it does not look as chaotic. I'm going to just focus on my red ones right now. Now, these red equations, these red shapes are all the same shape. These are all linear relationships. We know that because they're given by straight lines, right? So a linear graph, the general shape is a straight line. That might look like this, it might look like that, but either way, it's a straight line. All right. Now, these straight lines, if we take a look at the equations that we still have that are in use right here, you'll notice all of them have an x involved, right? You'll also notice that there are no exponents at play. And rather, our main focus here is that there are no exponents on the x's, and there are no exponents that have an x inside. Right? So I could, if I wanted to, I could create an exponent on one of these. Let's say this one right here. I could create an exponent on the number, but because the x itself does not have an exponent, I'm still working here with a perfectly straight line. I'm hoping you're able to follow that. That is, the equation has an x involved and no exponent on x. All right. Now, let's take a look then at some of the other shapes we have right here. Okay, so if I look at all of my green shapes, I notice, and I'll get rid of the other pieces so they're less in our way, we notice this general shape we're really familiar with. It's that U shape, it's that parabolic shape, right, where it looks like a bowl. It either looks like a bowl that's opening up or a bowl that's opening down. And all of these come from equations that look a little bit different. Right? Some of them have brackets, some of them do not, but there's something that's in common between all of these, and that's that they all have an x that's being squared. And you might say, well, Mr. Pasotka, I see this x that's being squared, even though there's something else with it. I can tell there's an x that's being squared, and I can tell there's an x that's being squared way down here, but I don't see it right here. And that relies on the previous lesson we did, expanding, right? If you were to expand this using your rainbows, using your FOIL method, using your area method, you would see that there will become an x being squared when this is expanded, and that's what tells us that what we're working with is a quadratic relationship, all right? So a quadratic relationship has that parabolic shape, which looks something like this, where it opens down, or something like this, where it opens up. And in the equation, it has an x that's being squared. Now, I want you to recognize that you might need it expanded in order to recognize that. And lastly, we have our exponential relationships. And I'm going to leave up a couple of these parabolic, a couple of these quadratic relationships at the same time as these exponential relationships so that you can really tell the difference. So these two exponential relationships we're looking at, you might say, well, hang on, it looks like they're curved just like the parabola. So how do we tell the difference? Well, the parabola, you'll notice, starts off steep and then it goes flat just for a little bit and then it goes steep again. And that's with any parabola that we're working with. Now that's not the case for these exponentials. The difference is they will be steep at one end, and the other end it goes very, very flat, and it will approach a certain value. So here it's very, very flat and then very, very steep, but it's only steep on one end, and it's only flat on one end, unlike, say, a linear relationship that we've already seen that's flat on both ends. Or unlike a parabola that we've already seen that is steep on both ends, right? So all of these exponential relationships are going to be flat on one end and steep on the other. That is, it will look something like flat and then steep, or it will look something like steep and then flat. All right. Now the equation, what do we notice about all of these equations that are here in purple? Well, all of these equations have an x involved just like before, and they also all have an exponent, just like our quadratic relationships did. The difference is what's in the exponent and the location of the x. The x here is not a part of the base. The x here is only involved as an exponent. The x here, again, is only involved as an exponent. Could I have other things in my exponent and still have it show up as a parabola? Or sorry, as an exponential? Yes, absolutely. But the key is this x must stay in the exponent. If I take this x out of the exponent, it's no longer an exponential relationship. So we'll need to make sure that if we're looking to find them, that x shows up in the exponent. Good, okay. So what I want you to do here, I want you to pause the video. I've got a whole bunch of colors, a whole bunch of different relationships here. I want you to pause the video. I want you to try and practice recognizing which of these are linear, which of these are quadratic, and which of these are exponential. Good, looks like we have just one linear relationship because there's just one straight line. We have a quadratic, that's a parabolic relationship here in red, and in black as well. And then in green, we have this exponential relationship, and in purple, we have this exponential relationship. Nice work. Now, and this is review, working with our tables of values. We've covered first differences in here. We've covered second differences in here. We've covered common ratios in here. The trick is that we're trying to do here is to put them all together. I need you to make sure you're comfortable recognizing, okay, if your first differences are the same, that tells you that what you're working with is linear. All right, so I want you to try it out. I want you to pause the video here. I want you to calculate all of your y values. I want you to calculate your first differences and see what happens. So we can see it's going up by 2 each time. So our first differences are simply plus 2, plus 2, plus 2, all the way down. Because all of these are the same, what we're working with is a linear relationship. What methods can we use? We're just checking first differences. If they're all the same, we have a linear relationship. All right, next we have ourselves this equation. Because we practiced recognizing the equations, we probably know where it's going, but I need you to make sure you're comfortable finding these because I won't give you this equation all of the time. Sometimes I'll just give you these y values. In this case, I want you to find your y values, pause, see how you do. Good, so here we have ourselves a quadratic. How do we know these second differences are all the same? And lastly, again, from the equation, you probably know what it's going to be, but I want you to fill in your blanks. I want you to find your y values, find your first differences, find your second differences, see what happens, and then we'll come together for our ratios in a moment. Good, okay, so firstly, we'll recognize, okay, we checked our first differences. Are they the same? No, they're not the same, and what that tells us is that we are not working with a linear relationship. Okay, then we checked our second differences. Are they the same? No, they're not. What that tells us is we're not working with a quadratic relationship. Does that mean we're working with an exponential relationship? No, there are other kinds of relationships, and sometimes there's no relationship between numbers. So we need to double check our exponential. We need to double check our ratios. Now remember, when we're calculating our ratios, we're finding out how the first differences are changing. We're not focused on these y values. We're focused on the first differences right here. So I want you to pause the video, see how you do. Good, so we divided our successive values. If you don't remember how to do this, I want you to head back to our past video. But we have ourselves, all of these ratios are common. That means it's exponential. How do we know? Because there's a common ratio. If all of these numbers were not different, we would have found ratios, but we would not have found a common ratio. Common meaning they're all the same. All right, so this piece, you know what? We've already covered this piece up on the first page. I want you to head back, double check. And then I want you to practice. Take all of these equations. I want you to identify whether we're working with linear, quadratics, or exponentials. And I want you to base that off of what we covered way up here. Good, okay, where you can see, and I'm sorry I'm so zoomed out and it's all tiny here for you, but I wish it was showing a little bit better on my screen. It's not, that's okay. Where we can see we're working here with an exponential because our exponent is the x. The x is inside the exponent. We can see we're working with a quadratic down here because the x is being squared. We can see we're working with an exponential because the x is in the exponent, a linear because there is no exponent on the x, there is no exponent we're working with where an x is involved. And over here, we have again a linear relationship, no exponents. Down here, we have ourselves a quadratic relationship because there's an x being squared. So again, if you followed along with us, fantastic work. I'm hoping you're feeling a little bit more comfortable comparing your functions.